convolution now. Get rid of that. Okay? So again, there's a definition of convolution, right? So you suppose f of lambda, we will define f of lambda, defined in a short interval from 0 to epsilon. So right there it is, there's an interval from 0 to epsilon, it's constant, and 0 otherwise, okay? So I didn't say 0 elsewhere. Okay? So there's our f of lambda. Then our f of negative lambda just reflects f of lambda around the y-axis. Okay? So we get this. And now if we replace lambda with lambda minus t, we shift t units. And if t is a positive number, we do this. And if we're integrating from 0 to infinity, well, actually, we're going to define this in this case for positive t. Okay? It could be defined for negative t, and that might be relevant if we were going from negative infinity to infinity, which we could do. Generally, going to get this. Okay. Well, actually, negative infinity, infinity is more general, but typically we're going to do this. Okay, well then, what is this product? Well, right here is your g of lambda, right? And then here is going to be your f of t minus lambda, f of negative t minus lambda. Okay? So here is, again, your f of t minus lambda. Okay, and we'll note that this is f of t minus lambda, right? So the reason we've done this is a picture of f of t minus lambda. And I was formerly confused about which side of the axis that went on because, again, I was bypassing steps, okay? And then I got myself kind of mixed up. Okay, anyhow, so don't do like I did. There it is. Now, the idea is simply that if we integrate this, well, what we're going to get is just the product of c with the value of g, essentially. Because our function f of t minus lambda times g of lambda is just going to be some multiple of this value, right? So now we have t minus epsilon, we have t, and we have these g values, which don't vary much. So here are the g values. Now the values here are c times g of lambda, because c is the value of this f function, right?
Right.
Okay, so the values are c times g of lambda, and that's it. The integral and the other values, of course, are here, because we're multiplying by this function, which is 0 everywhere else. Those are the values of c times g of lambda on this interval, okay? The result is the integral from 0 to infinity of f of t minus lambda g of lambda d lambda is approximately then just equal to
Eli.
is just the c times g of lambda, the
Right.
altitude of this interval, right, times this width. Okay? And that would be approximately true for any lambda in this interval. Okay? Also, this is equal to this for some lambda in the interval from t minus epsilon to t. In other words, at whatever value of t within this interval, this thing takes its average value on that interval. That's going to be the value of lambda that gives you the exact. Now, if epsilon is a small number, it doesn't make much difference. Okay?